Alright, this lesson's over graphing linear functions, section 2-3. Go over some vocab first. Rate of change, same thing as slope, defined as the change in y divided by the change in the x. Alright, what we can do is we can use this to find out if a function is linear or not. Okay, and the rule for that is that for a function to be linear, it must have a constant rate of change. Alright, now what you might see written out is this triangle like that. That's the Greek letter delta, and it means change. So you might see this notation, delta y over delta x. Change in y over change in x. So if you're given a table of values like this, first thing you need to do is determine which one's x and which one's y. Okay, so it's like a ship coming into land. Okay, the time that it takes and the distance from the land. Okay, so time in almost every instance is your independent variable, your x. Alright, because we can't control what time does. It's going to move forward no matter what. Okay, so that makes our distance from land our y. So we want to find the change in x, change in y divided by the change in x. So all of our changes in y is 350 down to 325. That's a change of negative 25. Okay, we get the same thing here and on down. Okay, our change in our x's we do in a similar fashion. Okay, and these all go up by 1, so we're recording this each hour. So when you do your rate of change, you take your y change, that's negative 25, and you divide it by your x change, that's 1, and we get a rate of change of negative 25. Okay, now we don't really care about that today. What we care about is that these are all the same. That's what this word constant means. These all need to be exactly the same for it to be linear. So this is a linear function because they are all the same. Okay, if all the rates of change are different, or even if just one of them is different, then it's not linear. Okay, for every data point you have, it has to be the same rate of change for everything. Okay, so let's take a look at this one down here. Okay, we're going to do the same thing, the change in y divided by the change in x. Alright, so our change in y, we've got 13 to 25, that's a change of plus 12. 25 to 29 is plus 4. 2 to 8 is plus 6. And 8 to 10 is plus 2. So this one's real easy to just dismiss as not linear. Okay, but that's not necessarily the case. Sometimes they give us tables where we're missing points in the middle. Okay, this one up here was really nice. 0, 1, 2, 3, 4 just gave us straight up. Okay, this one here, 2, 8, 10, that's kind of skipping around a little bit. So the way you tell on tables that skip around is by doing the y over x, the rate of change. So you take your 12, your change in y, divided by 6, the change in x. 12 over 6 is 2. Do the same thing with the second part. So change in y was 4, change in x was 2. 4 over 2 is also 2. Okay, so that tells me right there, since the two rate of changes are the same, that this is, in fact, linear. Even though the table looked initially like it was going to be non-linear. So just make sure every time do the y over x and y over x in that order. Alright. Next thing we're going to do is just simply graph a line. Okay, so this one we're given a slope and a point. So I've got a little two-step process here. Step number 1, plot point. Okay, so this one just straight out gave us a point to plot. Sometimes we have to go searching for it a little more, but this one we don't. So negative 1, 1, 2, negative 3. Alright, and then step number 2, use slope to plot more points. Okay, so the minimum amount of points you have to have is 2, so we at least need one more. You could usually want to try to get 3 or 4 just so you can get a good looking line on there. Alright, so this is going to be 5 halves, that's our slope. Okay, and you learned back in Algebra 1 a little saying for this. It's called rise over run. And since these are both positive numbers, I'm going to go in the positive direction for rise and run. So rise, positive, that's up. 1, 2, 3, 4, 5. And run, positive, is right. 1, 2. Plot a point there. And do that again. 1, 2, 3, 4, 5. 1, 2. Plot a point. Okay, we could even do the exact opposite. I could go negative and negative, because if I divide those, you get a positive still. So you can go down 1, 2, 3, 4, 5, left 2. And you can see that this point does in fact line up with all the rest of them. So once you've got 3 or 4 points on there, then you just want to draw a line through them, like that. Make sure your line goes through all of your points, okay, and not just doesn't stop. Okay, that would be a line segment, not a line. Okay, you learned about that in geometry. And then lines continue on forever, so you want to draw arrows on the end. Next example. Okay, this one we have to go searching a little bit more. So what they gave us right here is called standard form. Okay, we'll learn more about that later this unit. But this is not a good form for us to graph in. So we have to go kind of searching for some points or a slope or something to use to be able to graph it over here. So this method is called finding intercepts. So you've got your x-intercept and your y-intercept. This is where the graph will cross the y-axis, that's the one going up and down, and where the graph will cross the x-axis, the one going from left to right. Okay, we're going to use what's called the cover-up method. So basically, if you are an x-intercept, your point must be on the x-axis, which means the y-coordinate has to be 0. Because that's the equation here. We're not up, we're not down, we're right smack dab in the middle, we're right at 0. So you can, in effect, just cover up the y because it's getting zeroed out, and then just solve for what's left. So what's left here is 4x equals 16. Okay, just simply divide both sides by 4, and you get x equals 4. Okay, I'd like you to write it as a coordinate point. So the x-coordinate is 4, and the whole reason we covered up the y is because the y was 0. So there is your x-intercept. To find the y-intercept, you do the exact same thing, except instead of covering up the y, we're going to cover up the x. Because if you're on the y-axis, you're not left, you're not right, you're right in the middle at 0. Okay, make sure with minus signs as well that those come with you. So this is actually going to be negative 2y equals 16. Solve it the same way. We're going to divide by negative 2. Both sides, y equals negative 8. Write this as a coordinate point that we zeroed out our x, and our y we found out was negative 8. Okay, so this over here is our x-intercept. This one over here is our y-intercept. Told you on the last page that you need a minimum of 2 points. Well, we have exactly 2 points. So we don't really have to go find anything else. I can just plot these 2 points, 1, 2, 3, 4, 0 right there. And 1, 2, 3, 4, 5, 6, 7, 0, negative 8 down here. And then draw a line through it. And that's it. I don't need to do anything else. I was able to graph my line and I found my intercepts. Those are the 2 things the problem asked me to do. Find the intercepts and graph. So we're done. Alright, now most of the time when we're given a standard form, and this problem isn't exactly in standard form wouldn't have a fraction, okay, but it works the same way. Most of the time when we're given this, we're going to convert it to what's called slope-intercept form. So you've heard this before, it's called y equals mx plus b, where m is the slope and b is the y-intercept. Okay, so I've kind of whittled this all down to a 2-step process. So step number 1, move x term to other side. So you'll notice that in this form, the standard-ish form, x and y are on the same side of the equal sign, but in slope-intercept form, they're on opposite sides of the equal sign. So we need to make that happen by moving the x term over here. So I do that since it's a positive x by subtracting x from both sides. I get 3/4 y equals, and I like it to be in the same order, mx, x first, then b, And I can't combine those because they're not like terms, so I'm going to write negative x plus 6. Alright, so step 2, you are going to multiply slash divide, just kind of depends on what this number is, to cancel coefficient of y, sorry. Alright, so just again depends on this number. If it was just a 2, we just divide everything by 2 and be done with it. Since it's a fraction, we're going to have to take a little more care. So you learned when you were solving equations in Algebra 1 that to cancel out the fraction, you multiply by its denominator. And whatever we do to the left, we also do to the right. So the reason this works is because it's like 4 divided by 4, which cancels out. That leaves you with 3y. And over here you have to distribute that 4 to both terms. Negative 4x plus 24. Okay, we still have this 3 in front, so don't stop too early. Make sure to rid yourself of the 3 as well by dividing by 3. And you get y equals, you want to leave this as a fraction. 4/3 already doesn't go into each other, and you definitely don't want to do 1.33. We don't round in math, we try not to at least. So here 4/3, and you want it as a fraction because you want to be able to do rise over run anyway for your line, so that gives you a perfect rise over run. 24/3 is 8. So there's our slope-intercept form. Now to graph it. So if we go back a couple pages to here, plot a point, use the slope to plot more points. That's our method of graphing. Well, they didn't just come out and tell me what the point is, but I know I have one because it's called slope-intercept form, and I have what's called a y-intercept. That's this number right here, the 8 is my y-intercept. Alright, that's a positive 8, so I'm going to go up on the y-axis 8 units. Okay, then I can use my slopes. That's why this form is so good. It gives us exactly what we need, a point and a slope. So from my point, go down 4 because it's a negative 4, and right 3 because it's a positive 3. I can do it again. Remember, you can always do the opposite. You can go positive 4, negative 3. That works out the same way. Okay, draw a line there. Put some arrows on it. And that's slope-intercept form.